Okay, so guys, we're going to be talking about solutions to quadratic equations. So solutions to a quadratic equation are the points at which the function intersects the x-axis. And guys, points that intersect the x-axis, what are those called? X-intercepts, okay? So guys, solutions are referred to as zeros, roots, or x-intercepts. These words are all interchangeable. So when someone asks, what are the solutions? They're asking, what are the x-intercepts? If someone asks, what are the zeros? They're asking, what are the x-intercepts, okay? All of these words are interchangeable, okay? So today we're going to be focusing on x-intercepts, which we're going to call them solutions. Okay, so these are the different types of solutions you're going to get. You might get something, and we're doing quadratics. So remember, quadratics are U-shaped graphs. They have a parabola shape. So if I were to graph something like this, you guys see how it has two x-intercepts? That means it has two solutions. You could also graph it like this. You might see something like that facing down. It has two x-intercepts, okay? So those are different types you might see. Okay? Something that has one solution might look like this, where it just touches the x-intercept one time. That's one solution. It could also face up like this. That's one solution. And if it has no solutions, what do you think it's going to look like? Yep, it's going to be a quadratic graph, but it's not going to touch the x-axis. So maybe it might look like this. It can look like that, but it's not going to touch the x-axis. There's going to be no x-intercepts. Okay? So let's look at some examples. We're going to go ahead and practice graphing. So I'm going to graph this quadratic equation, and I'm going to do that by making a table. I'm going to make a table, so I'm going to pick points, and I'm going to plot the points in my graph, okay, using this equation. Now, a trick that I like to use to figure out what numbers I should plug in is I'm going to factor this. So I want two numbers that will multiply to -3, but add to give me 2. So what, 3 and -1? Yep, 3 times -1 is -3. 3 minus 1 is 2. So I know that I can write my factors like this. I have y equals, and then my factors are x plus 3 and x minus 1. Okay, so I just rewrote the equation. They gave me, and f of x is the same thing as saying y. So they gave me y equals x squared plus 2x minus 3. I just rewrote it like this. Is that okay so far? Okay, so let's talk about it. I want to figure out what my solutions are, what my x-intercepts are. Okay? So guys, any point along the x-axis, what is the y value? 0. So guys, if I want to figure out what x values will make the y 0, well, what would x be here to make it 0? -3. So that means I know the point -3, 0 is a part of my graph. So I'm going to go ahead and plot that. -3, 0, that's my x-intercept. What if I plug in a 1 here? Won't that be 0? Okay, so that's another x-intercept. So I know these 2 points exist. 1, 0. So I know I have -3, 0, I can put that on my table, and I have 1, 0. I can put that on my table. I have my x-intercepts. Okay, now let's just find out some more points. I know my graph, don't draw this, but I know it's going to look something like that. It's going to look something like that. But let's figure out the exact points. Okay, so I'm going to pick some more points. How about we test out the point? Let's see what if we plug in a 0. So let's plug a 0 into my equation. So this was my original equation. I'm going to plug in a 0 though. And what do we get? -3. So I know 0 goes to -3. Okay, let's try -2. Let's plug in, oh no, let's plug in -1. So let's see what happens when I plug in a -1, what my y value would be. -1, -1. So -1 squared is a +1. 2 times -1 is -2. 1 minus 2 minus 3, -4. Okay, so whenever I plugged in a -1, I got out -4. So -1, -4 is here. All right, so guys, that's my graph. It'll look like that. Okay. Now, of course, if you don't want to factor and figure out what your x-intercepts are going to be, you could just guess and check. You could just plug in numbers, plot the points, and try to figure it out that way. Okay. But I think this is a more efficient way of figuring out what your x-intercepts would be instead of guessing and checking. Okay, let's do another example. Let's move on to number 2. Is this number 2? Yeah. Okay. All right, so first I'm going to factor this because I have a negative in the front. So I'm going to factor out a -1. Okay. I'm going to factor out a -1. Oh, let me get rid of these parentheses. So I factored out a -1. So what I have is x squared plus 10x plus 25. Okay, I pulled out a -1. Now let's just go ahead and factor. I want two numbers that will multiply to give me 25, but add to 10. 5 and 5. Okay, so that means I'm going to rewrite this equation as y equals -1 is on the outside, but I have x plus 5 times x plus 5. Can't I just write this as x plus 5 squared since I have two of them? Okay, that's what I'll do. Okay, so I just rewrote this top equation as this. Now let's figure out what my solutions will be, what my x-intercept would be. What would I plug into x to get the y value 0? -5. So I know if I plug in a -5, I'll get 0. Well, that's my x-intercept. So let's go ahead and plot it. 1, 2, 3, 4, 5, right here. That's where my x-intercept is. So I know in my, yep, there's only one solution. So I know if I plug in a -5, I'll get out 0. And then from here, I can just pick points. So how about we plug in a -7 and a -3. And let's see what we get. I already know it's going to face down. Do you guys know how I know it's going to face down? Yeah, because there's a negative in the front. It has a negative in the front. So I know it's going to face down. It'll look something like that. But let's get our exact points. Okay, so I'm going to plug in a -7. So how about I plug it into this problem here? I'm going to erase this x, and I'll plug in a -7. So -7 plus 5, that's -2. And then we're going to square that and get 4, but then there's a -1 here. So we get -4. So when I plug in -7, I get out -4. So here at -7, I'm right here. And I guarantee you this one will also be a -4. But we can go ahead and show our work. I'm going to plug in a -3 this time. -3 plus 5 is also -2. Oh, wait, I plugged in a -7 last time, didn't I? Oh, and I got 2. And then I'm plugging in -3 this time. What do I get? +2, but what's 2 squared? 4, and 4 times -1, I get -4 again. Okay, so that's my graph. -4. Okay, so guys, if you wanted to, you could just, oh, I'm going to try -2, -1, 0, 1, 2, but you really wouldn't get a good picture, right? So this is a good strategy to use to figure out what x value should I plug in so I get a nice U-shaped graph. Okay. All right. I'll do one more with you guys. How about we do number 3? Okay. So this one, I'm going to divide everything by a -1 first. So I'll get y equals -1. Oh, sorry, number 7. Flip over your page. Okay, so this one's a little tricky, guys. Are there two numbers that will multiply to give me 17 but add to -8? I can't think of any. 1 times 17 is 17, but those don't add to -8. And -1 and -17. So guys, can we factor this? I don't think so. So we can't use that little trick of finding the x-intercepts. I would assume that there are no x-intercepts. So let's see what this graph will look like. So it might be no solutions, but you can still graph it. We'll still have a graph. The graph just won't touch the x-axis. Okay? So let's just pick some numbers. I'll plug in a 1 and a 0. I'll try 0, 1, 2, 3. Okay, so I'm going to plug in a 0. If I plug in zeros here, what do I get? -17. Okay, that's really big or far down. Let's plug in a 1. 1 squared, and then it becomes negative because there's a negative in front. Let me erase this so that it looks better. Okay, so we're going to plug in a -1 here and a -1 here. So -1 squared is 1, but this becomes a -1. This will become a -8. I'm sorry, I'm plugging in 1. I'm plugging in 1. Sorry, not -1. Okay, so 1 squared is 1, but it becomes minus. 8 times 1 is just 8, minus 17. Okay, so what will that be? -10? All right, now let's plug in a 2. So I'm going to use the same equation up here. I'm going to plug in a 2 this time. So this is 2 squared, which is 4, and there's a minus in front. This will become 8 times 2 is 16, minus 17. What will this be? What will this be? Looks like -5. All right, let's plug in a 3. So if I plug in a 3, 3 squared is 9, but this will be a -9. Plug in a 3 here, and I get 24. So let's think. 24 minus 17 is 7. -9, so -2. Okay, let's try some more numbers. Let's plug in a 4, see what happens. All right, number 4, we're going to plug in a 4. We get -16 plus plug in a 4 here, 32 minus 17. What will this be? Is it -1? Yeah, -1. Okay, so let's graph these points. 1 -10 is down here somewhere. 1, 2, 3, 4, 5, 6, 7. Right here. 2 -5 is right here. 3 -2 is right there. And 4 -1 is right here. Okay, I see it getting really close. I'm pretty sure it'll go down like this, where that's there and that's there. Okay, so those are your points. All right, so that's it, guys. That is how you graph these quadratic functions using points and x-intercepts. I'm going to have you guys practice the rest. Real quick, guys, let's go back here so we know how to write our answers. What are my solutions for this first example? Yep, so when I say what are my solutions, I'm talking about what are my x-intercepts. So looking at the graph, I know that my solutions are -3 and 1. So that's what that one is. If I look at my other graph, my solution is my x-intercept. So when it asks what are the solutions, I would put -5. That's where my x-intercept is. And then for this one, did we have any solutions? No, so you would just put no solutions. We could still graph it, but there's just no x-intercepts. All right. Okay, here is question 6. And it reads, y is 2x squared plus 6x. Now notice, guys, we have A and B, but we don't have C. Okay, so what I'm going to do is, first I'm going to look for my, the greatest common denominator, or greatest common factor, sorry. These both can be divided by 2, and they can both be divided by x. So 2x is my greatest common factor that will go on the outside. And let's see what we get. I'm left with x plus 3, because those x's cancel, one of those cancel, the 2's cancel. That's what I'm left with. So let's think about what x values would give me 0. Well, if I plug in a -3 here, -3 plus 3 is 0. So this would be 0. And if I plug in a -3 here, well, 0 times -6 is just 0. So I know that when my x value is -3, the y value is 0. So that's one of my x-intercepts. Let's try again. If I replace the x value with a 0 this time, let's see what happens. For every x, I'm going to plug in a 0 this time. And let's see what I get. I plug in a 0 here and a 0 here. So let's see what the x value 0 will yield. 2 times 0 is just 0, times 0 plus 3 is 3. 0 times 3 is just 0. So I'm also at the origin. That's where my other x-intercept is. So I know that my graph will look something like that. Okay? But let's go ahead and find some more points by plotting. Let's do 1, sure. I'll plug in a 1. So I'm just going to use my original problem up here. So let me erase all of this. I'm just going to go back and use my original equation. Might be easier. Okay, so if I plug in a 1, let's see what numbers I get. 1 squared is 1. This will be 2 plus 6, so I'll get 8. So if I plug in a 1, I'll get 8. So that's there. It'll look something like that. And let's get 1 down here. How about I plug in a -1? And let's see what happens when I plug in a -1. Okay, so I'm going to plug in a -1 this time. -1 squared is just 1, so this becomes 2. 6 times -1 is -6, so this is -4. So at -1, I'm down here at -4. All right. And guys, it's going to look something like this. Yeah, it'll be a little bit down. I don't feel like plugging in a decimal, but if you plug in -1.5, you'll be down here somewhere. I'm just going to estimate it. But that's what your graph would look like. Any question? Yes.
How do you know like what numbers to plug in?
That's a good question. So how do I know what numbers to plug in for x? You could either guess and check. So you could always just plug in a whole bunch of numbers and try to form your graph. But the more effective way or efficient way is what I did is I factored and I found out what my x-intercepts were. So that's what this process was. I factored first, and remember when we factored, we got this, x plus 3. So just by looking at this, I know if I want 0, this would have to be a -3. So that's how I knew what one of my points were. And I also know if I want this to be 0, this one would have to be 0. So those are my x-intercepts. So that's how you figure out what your x-intercepts are. And then from there, you can figure out, okay, well, I know my graph is in this general area. So pick numbers around it to make your graph. Does that kind of answer your question? Okay. And if we look at previous examples, what I did previously, like for this first question, I figured out what my x-intercepts were, and I do that by factoring. So if we go back, if I go back, we rewrote this equation. We rewrote this top equation as this. Let me highlight so y'all see what I'm talking about. We rewrote this equation as this. And by looking at this, I know my x-intercept would be -3 and 1. Because if you plug those numbers in, the y value is 0. So I knew -3 and 1 were my x-intercepts. So my line will go through those points, and I just picked numbers in between it, after it, and figured out what those points were. Yes. Oh, okay. Thank you. So you said you got -4.5? So when you plug in a -1.5, you got -4.5? Perfect. Oh, and that's where I was. Nice. Thank you. Any other questions, guys? Yes. Yep, this is the x-intercept. Yep, it's also a y-intercept. Any other questions? Yep, so the axis of symmetry would be x equals -4.5. Yes, that's the axis of symmetry. Oh, sorry. Yes, sorry. -1.5. That's the axis of symmetry. It goes through -1.5. Any other questions? All right,